Hi, welcome. If you are here for the Teaching with Tinkercad webinar series, you are in the right place. So we are going to get started with a warm-up question. So tonight we're going to be talking about developing a product mindset with your students. And we thought, when you're launching a product, it could be kind of thinking about launching a new project or a unit of study. So we're wondering, when you're thinking about launching something new, you might also want to think about some of the limitations or the constraints that you might face. So in the chat, do please feel free to introduce yourselves to each other. You might say where you're signing in from or what grade level you teach. So do please feel free to say hello. But we also would like to just hear some of your ideas about what are some constraints that you consider in launching a new project with your students. So maybe it's time. Maybe it's the number of students that you teach. Maybe it's the time of year, even thinking about the schedule around standardized testing, for example. So what are some constraints? Oh, sorry, Randy, do we have responses already?
Yes, we have some responses. We're seeing alignments here, time, like you said. Let's see. A lot of introductions from people at the moment, but I'm sure more answers will come in soon.
Awesome. Yeah, one of the things I thought about when I was teaching, because I taught middle school and we did a lot of interdisciplinary projects together. So some of the things I would think about when I was planning units of study was what are some of my colleagues teaching their students and what are some ways that we can intersect what we're teaching? And this whole, oh, sorry, Randy.
We're seeing, let's see, engagement, prior knowledge, that's a good one. Constraint time again, seems like that's popular. Time management, yeah. And yeah.
I wonder resources as well, the materials that you have at hand is definitely a constraint.
Yeah, tech limitations for sure. We see that a lot. Resources available, prep of materials, standards. Oh, 3D printing. Time for 3D printing.
Huh. Well, that's a good one. Yeah, thinking about what type of fabrication equipment you have too. If you have a laser cutter, that might be faster to make your students' designs. But if you're using a 3D printer, you've got to build in the time to print.
Yep. It seems like time is the overwhelming answer most people have.
Well, time is of the essence too tonight because we have a lot to present. So I'm going to keep this question in your mind. So what are some constraints that you consider in launching a new project or unit of study? So keep it going in the chat. We're always so impressed by educator engagement in our webinars. This chat is your chat. So do please feel free to introduce yourselves to each other. We're so happy that you're here. So this is the Teaching with Tinkercad webinar series. This is episode 3. If you want to watch past episodes, it's on YouTube in a playlist, and we'll be sharing that link with you later and also in the email that you'll be receiving. Our topic for tonight is developing a product mindset with Tinkercad. So thinking about how you can help your students go from idea to prototype into product, and then thinking of all the steps in between, and then even beyond the launch of the product. So my name is Kellyanne Mahoney. I am a youth program specialist at Autodesk. I was a teacher in the Boston Public Schools for 13 years prior to joining Autodesk. I actually taught middle school English. So one of the things that I really think about in these webinars is how can we include, all subject areas and make it relevant. Randy is also our co-host for the evening. Randy, you want to say hi and introduce yourself?
Sure, I'm Randy. I'm on the youth team in K-12 education. I work for Tinkercad and Instructables, and I'm really excited to be here helping out tonight.
Awesome. Thank you, Randy. So he is our chat vocalist as well. So Randy, please feel free to interrupt me when I'm talking if there's any questions that come up that are interesting. And we'll also have a live question answer later. So ways to connect with us. We're on Twitter, we're on Instagram, we're super cool. We're on TikTok now as well. So these are the handles that you may use in order to tag us or to see what we're up to. And you may also use the hashtag #TinkerTogether. We are all part of the Autodesk family. So Autodesk empowers innovators with design and make technology to achieve the new possible. And that's something we're going to be talking about tonight. Very excited to introduce our first guest of the evening, Guillermo Melantoni. Not really a guest because he's part of the Tinkercad family. I would say he's the
You have
patriarch.
a choice, basically.
So he is the director of product management for Autodesk. Did you want to say hi, Guillermo, now, or do we want us to wait?
No, that's fine. I'll say hello now. Yeah, I've been sort of running Tinkercad since 2013, so 10 years ago almost. And yeah, originally from Uruguay, where I was a teacher. So I was also on that side, but for university, I was teaching from 18 to 20-something-year-olds.
Nice. Lots of former teachers in the house tonight, and current teachers mingling together. So good stuff. And we're super excited for Guillermo to be here. The magic behind Tinkercad is going to talk about some new magic that is now part of Tinkercad. We're also joined by Jemuel Stephenson, who's the founder and CEO of Fabric Origins. He's also a studio manager for the engineering studio as part of the Digital Ready program in Boston. So he'll talk a little bit about that as well. How to participate, you're already doing a great job, so do please still stay engaged in the chat. We'll be pushing out some questions to you as well, but do please continue to connect, and do know that we're all familiar with Zoom, I think, at this point in our lives, but there's 3 icons on the bottom of your screen that you should focus on. If you just want to chat it up with people in the webinar, your colleagues, fellow educators from around the world, please use the chat function. If you want to ask a question to the Tinkercad team, so we're here to answer your questions in real time, please use the question and answer feature, because that will be an easier way for you to get your answer and for it to not be lost in the chat. So there are real people answering your questions, so you'll be able to meet some of these fine folks later today when we do our question and answer at the end. So the goals for this series are kind of the same across each episode. We'll be emphasizing different things during different episodes. So just thinking about ways that you can collaborate with your colleagues and thinking about how to design projects that students can engage in across disciplines. Also, just all the awesome stuff that we're talking about tonight, how can we make it accessible to all students? So that's definitely one of the goals for the whole series. Thinking also about the future of work and emerging trends in technology that will not only excite your students, but also enable them to achieve the new possible in thinking about future careers that are fun and meaningful. Another one of our goals is to think about how, when it's time, particularly once your students turn 13, to move from Tinkercad to Fusion 360. So we'll talk a little bit about that today too. And last but not least, please, throughout the episode tonight, ask questions to the Tinkercad team, and we will have a dedicated section at the end too for live question and answer. So there are 2 more episodes in this particular series. So on Thursday, April 27th, and just in time for Robotics Month as well, we're going to be talking about introducing robotics with Tinkercad. Our agenda for this evening: we're going to start with Guillermo, who's going to talk about building momentum around a product mindset. He's also going to be talking about an exciting new workspace in Tinkercad too. Next, I'm going to just be talking about kind of extending what Guillermo is setting up for us around what product mindset means and how you can enable it in teaching with Tinkercad. I'm going to be sharing some resources for you to take away and even implement next week in class or tomorrow. Then we're going to hear from Jem, who's going to talk about the fabrication studio that he owns in Boston and how he teaches students and invites them into the studio in order to develop a product mindset. And last but not least, we are going to do a live Q&A. So before we get started, we want to take a pulse of the room. So just wondering, what subject area do you teach? Zoom only allowed me to put 10 different categories. So try to choose one or more. You can choose one or more that's most relevant to what you teach. So I can't see everything right now, but it does look like computer science and coding is, I think, in the lead right now. Randy, what are you seeing?
Mm-hmm.
Computer science followed by 3D design, and robotics, I think, is in a sort of distant third there.
Huh.
Not,
Wow.
Not so distant compared to some of the others, but I could share this when we're done.
Yeah, so just take another minute or two. You can choose more than one as well, because we know that we are sometimes wear many hats when we're teaching.
All right, I'm going to share it.
Thank you, Randy. All right, are you sharing the results now, Randy?
Yes, I am. I'm sharing the results, right?
Fantastic.
So computer science obviously is in the lead. Design 3D, robotics has shown up there. Engineering, which is broadly engineering, and then we have some art, math, technical arts. Yeah, it's all over.
Well, we're excited that you're here, and it's really nice to have such a diverse audience joining us. So we're going to move on to hearing from Guillermo about building momentum around a product mindset. Guillermo, take it away.
Awesome. Should I share my screen then?
Yes, please. You can usurp the screen for me. You are a co-host, Guillermo.
Oh, I can steal it?
You can steal it.
Awesome. Okay. I hope you're seeing the right screen.
We see your slides.
Perfect.
Now
awesome.
they're in presentation mode too, Guillermo.
Yes, that's
fantastic.
what I wanted. Okay, well, so welcome everybody. So a lot of people also from South America. So buenas tardes, buenas noches, boa noite, from Brazil. I wanted to talk a little bit about product mindsets and mostly about how are we trying to apply that to Tinkercad and sort of follow some steps of how kids evolve on the user application into that. So the first of all, again, as with my former sort of life as teacher, trying to define things, right? Because we all love defining things. And I was just trying to figure it out, okay, we can talk about product mindset, design thinking. Sometimes we probably use all those terms sort of at the same time or conflating them or confusing them. Actually, I also had to spend a while just looking at what people say about it and just realize that the way I wanted to propose this is just do a little bit of an organizing this, right? So first of all, in general, when people talk about product design mindset or product mindset, it is a concept that is very tied to industry, right? It's a concept that came from industry, came from people that are looking for optimization on the work, right? And but at the end of the day, what they're trying to talk about is how they can focus on creating meaningful value for their customers. We don't have a customer, right? So we have a problem to solve. So I would say focus on the way I would adapt product mindsets in our world would be on focusing on creating a meaningful value while solving a problem, right? So, and it's funny because the more, I mean, I'm an architect, or I used to be an architect back like 25 years ago, right? The more you read about architecture, the more difficult it is to define architecture because the thing gets longer, right? The same happens with design. So I'm sorry if anybody here studied sort of design, but to me, design equals to solving a problem with a physical artifact, right? And if it's nice, awesome, right? But nice is very subjective. But if you're solving a problem there, that's what we're trying to do. And that led me to the design mindset, which felt like this, like a very solution-focused and very action-oriented approach to the creation of that object that uses design thinking, right? So that's something I think that we can apply much more, right? And then as we get into design thinking, or what is design thinking, this is probably the easiest one, or the one that we probably know better about, which is this sort of very iterative process, right? In which you understand the problem, or you empathize with the customer or the user, or whatever is the problem, right? You prototype, you test, something goes wrong, you prototype again, you test again, something goes wrong, but maybe less or more because you realize you have to go the other way later, right? And until at some point you get to what you want, right? So a continuous cycle of rinse and repeat of prototype, test, what did you learn? And I try to not say failure, because failure is a charged concept in our heads, or that we were told, like or you say, oh, you're a failure in a class. Well, that's wrong, right? We know that's a no right now. But failure got ingrained or get hard coded in many people as a bad thing. And as long as you learn from what happened that was not expected in what you're designing, that's great, because next time you'll do it better. The next time you'll figure out, oh, what happened here, this is too thin, so I need to make it thicker, so now it won't break. Now I made it too thick, so I'm using too much material. And so all those things, those iterations are very important. I have never seen a project that comes out perfect from scratch. And if it does, there's something wrong you have not found yet. So that is a little bit of what the way I'm kind of trying to propose this. And design thinking, the concept was introduced by IDEO, right? This firm, and this is the way they thought about it. You frame a question, you gather inspiration, right? You articulate the problem, right? And that's very important. That's just, what are you trying to solve? If you cannot articulate what's the problem, there's no design later, because what are you solving for, right? So, and then of course, gather inspiration, generate the ideas, make them, right? Make ideas tangible. It's just do the thing, right? Test it. And what I don't see a lot on this graphic, which is the reason why I like another graphic better, but this is sort of the beginning of everything. So I just wanted to also respect the fact that they came up with the whole concept, is although there's lines going all over the place, it doesn't feel like a cycle in the way that this other one does. So in which what you see here is, and this one is actually also, it's hard to understand where it starts, right? But kind of starts here with empathize, right? It goes to defining the problem. It goes to ideation, prototype, testing, and again, rinse and repeat, in which probably the problems are going to get smaller and smaller until you just say, okay, this is where I stop. This is a minimal viable product, or whatever you call it, if you're already in the business side. But again, when we talk about product design mindset, there's a lot more happening there, and a lot more concepts going there that could eventually be interesting for maybe a more advanced level at maybe at K-12. But in general, I would say that it can be more aspirational at our K-12 level, but it's a North Star. It's kind of where we're trying to go. We're trying to say, this is the way industry works, and let's try to see how you get there. So the question is, how do you get there, right? And most of it, what are we doing to help you get there? Because I would love to think that Tinkercad, the way we make Tinkercad and the way that we've exposed some things on Tinkercad, are subtly taking you along the road into that, right? Into being able to apply this design thinking, and to be able to get that design mindset, and eventually get in that product design mindset. Of course, if we are thinking about a classroom at, I don't know, elementary school or middle school, people still don't know what they're going to be doing. Even in high school, they still don't know what they're going to be doing. But there's already some hints of directions. But below high school, everything is very generalist. So we're not going to get, I don't know, 80% of the class becoming designers, right? I mean, maybe it's a 5% or something like that, right? But for everybody there, design thinking as a method has nothing to do with actually making a design, right? It has to do with a flow in which you understand, find a solution, test, and keep going, right? It could be anything. It could not have only to be applied to manufacturing or to making or to anything like that. So I think it applies for everybody. But now, as we go into Tinkercad, the first thing that people know in Tinkercad is the first approach is what is familiar to a Tinkercad user before Tinkercad? Probably no CAD, right? I mean, the first time they're going to do something that ends in CAD, it's probably Tinkercad. But there's a high chance that we're doing Roblox or playing Minecraft, that they have all sorts of kind of bricks or systems of interlocking systems of bricks with plastic, right, at home, right? And that is what they know, right? And I think that in every single classroom I visited, especially on elementary school, there's a bin somewhere with all these little blocks, right? The cubes and the spheres and the cones and all that stuff. So we see Tinkercad as the first piece is like that aggregation, right? Just we make things by aggregation. We don't start with a sketch. right? Starting with a sketch is an incredible level of abstraction that is not there at the ages we start on Tinkercad. It's not there. It's not nobody's fault. It's just our head is not prepared for that, right? I mean, our head is barely prepared to understand depth on a screen when we are 6 or 7 years old. I mean, probably now better because of games and everything, but in general, that's something that happens. I mean, there's a whole cognitive sort of evolution in that sense, and the abstraction of 2D to 3D is pretty tough. I'm sure that if I ask anybody 5, 6, 7, 8 years old how to build a chair, they will think this way first, before starting to think about, okay, well, there's 4 legs and the seat and this and this, and this is how we build it, right? Sometimes I think we expect more in that sense, and this is not wrong at all, right? This is a great step, because from there we can go and keep talking about other things. So once you get there, right? Once you get there, that's when kids can start understanding other concepts, because the whole idea of grouping or basically adding as subtracting, I mean, you can also equate into Minecraft, right? So you're adding blocks for mining. As you get a little deeper into that, well, we can tell you, okay, well, now you have all other options. You can be more precise, because you can be precise in Tinkercad in general, right? By just adding dimensions, but they're not in your face all the time, right? So, but if you really need something like this, I mean, you have the ruler, you have the work plane to be able to do different things. And again, this is not a Tinkercad class, so I'm not going to be explaining each of the commands. But my point here is that there is a kind of an increasing level of power, right, which allows you to get to more complexity, and you could still use all these commands in a very simple way, but you can also scale. I mean, it's not on other applications, more like professional ones, everything is there at once since day one. It's pretty hard to understand, right? So I would like to believe that if somebody wants to just work simply on Tinkercad, they can. If they want to use the same commands for something extremely complex, some workflows they do and some things they do just leads there, and it's just a matter of being ready for that. I'm going to explain a couple of those things in a second. But now, if you start with parts like here, right, and then you go into creating shapes like the ones on the right, maybe something that some people would start thinking is, hey, can I reuse this thing? And the answer is probably yes, please, right? So the idea of starting to create a library, it's very important, not only because you're reusing in terms of saving time, but also you're starting to learn how things are made, right? I mean, and this is just, I just Googled bill of materials of whatever, right? I just grabbed something that didn't have brands, right? So I just put it there. And if you start looking at this, brackets, rubber seal, hinges, screws, all those things, you just buy them. You don't design a screw. If somebody's designing a screw, there's something wrong there, right? So unless it's a very special screw, you don't, right? So there's a collection of new things you already done that you can reuse, and things that are just coming from the market, right? This is why my MasterCard or those libraries are very important, right? So as we evolve and get kids more used to not only building more complex things, but also starting and to understand that a design is a collection of those elements properly set up together, right? At that point, all of a sudden, the world kind of changes a lot in the way that people work. And the other thing that probably you want to do at that point is maybe you want to simulate it, right? So we've had simulation for a while on electronics, right? So if you're an Arduino, if you're in microbits, or just in any kind of circuit, you can test it out. You can see if that LED is going to explode, which is probably very fun to make LED sort of blow up in real life, but it's expensive, so you don't want to do it. So how can we simulate on the 3D world? And I saw already some people out there that probably already have been playing with SimLabs. So yeah, we have something there. I'm going to talk very briefly about it in a second. We'll probably want to have a whole webinar about that later in the day. But the simulation part here is even before manufacturing, but even before going into the process of really making the physical thing, just test it out, right? Against some assumptions that you make. And when things get really complex, maybe it's the right moment to say bye-bye, or to say, okay, see you later for this project, because it's too much. I need more, right? And I need more, and that more doesn't make sense to be added to a simple, or to a product that's trying to, again, not alienate the people that are starting, right? Because if not, we will become yet another Fusion, yet another Onshape, yet another something else, right? And so that's why we built the workflows that lead from Tinkercad to Fusion, and with the unique aspect there that what you take from Tinkercad to Fusion, if you use primitives, is native geometry in both. So you don't have you have full power of Fusion of solid modeling on the things that you made on Tinkercad. If you use primitives on Tinkercad and use the Send to Fusion workflow to their side. So if from making better renderings to having better resolution for 3D printing, or using a CNC, or doing more simulation, all those things are available in Fusion 360 later. So we just want to make sure that we get kids excited and curious about what can happen and what can be done. Just the level of agency that you can have today by from a few years ago, right? Understanding that you have electronics to work with, you have a 3D printer somewhere there. I mean, at school I have one, at private library I have one. So 3D printers, when I was 10 years old, there was one of the Jetsons, right? I mean, they would tap something on a wall and they get the food from something there, right? But that was science fiction, right? My first 3D printer, the first 3D printer I saw was in 2006 at Autodesk. It was a $180,000 Stratasys, right? That looked like a fridge and made things this size, this big, right? So today we can do that with a $300 printer, right? So things have changed so much, expectations have changed also so much. There's so much power and so many opportunities for kids today, right? With such an open world in terms of, yes, an application that is not only free, but it's simple to use, that can be applied very clearly on STEM or STEAM education, that is very tied to the way you work with electronics, or with a 3D printer, or maybe with a small CNC, right? All that gives an agency and a possibility for kids to understand, hey, I can do this, and maybe I can do this for a living later, right? So all of that is to us, it's really, really one of the things that I'm going to talk for myself. It's just that makes us wake up and go just like rushing to work, and work meaning just rushing to the desk, right, from the bedroom, and doing what we do here, which we all love, right? Because many of those kids will become the workforce, right? Either as designers, or as machinists, or as electronic engineers, or doing mechatronics, or in a factory, right? I mean, whatever you do, right? So you have to start somewhere, and I think that if you start on Tinkercad with zero background at that point, and by doing so simple designs, you're starting to learn, or to teach, or to communicate to the kids the basic aspects of how you design, how you approach design, just basically that design thinking and creating that design mindset, right? That can lead later to that product design mindset, which this is going back to the beginning and then just going to a couple of quick demos. This is the way, at least I see it, right? So design thinking is the flow, right? The mechanism, and product mindset to me is more like an North Star, right? And again, I know that some high schools are actually creating products almost like not commercial, but almost there, just and some others are not, or maybe you are earlier in the education cycle. But all of that, but I think it's a great North Star. You might or might not get there within K-12, but it's a great inspiration. That's a source. That's where I want to go with these kids. So with that said, I'm going to now try to show some of those examples on here, right? So let's say, for example, I mean, we all know Tinkercad, so I know how to start with Tinkercad from scratch. But I was here just playing with code blocks, and I hope that everybody has at some point seen code blocks. And if you don't, please go. It's just there. It's one of the 3 spaces we have. But I mean, without kind of, I mean, I could have started maybe just putting a cylinder on the screen on a normal 3D editor, putting another taller cylinder, making a hole, and just say, okay, this is a flange tube, whatever. But in that next step that I was mentioning is, what if I can make a flange tube that can have some sort of ratio between the diameter and the distance of the screws to the holes, to the border, and the amount of screws that you need and everything. And that's the foundation of parametric design. And parametric design on mechanical CAD is definitely very important, right? Also in architecture, if you think about Revit and all those things, I mean, everything is moving into that side of the world. And what I did here is an object, right, that can this kind of flange tube that basically you can define amount of screws, the size of the plate, the radius, and has already some kind of relationships between all the variables. So if by making just simple changes in here, I will get to different end shapes, right? So in this case, this part is smaller, right? So that is a fundamental shift in the way you think. And that's one of the reasons we made code blocks, right? Because at that point, we are mixing computational thinking and the way you have to think about programming and introducing variables and things like that, and loops and just a way of defining code into, okay, this can make these kind of objects. And of course, after that, you can make a shape. And the reason I'm saying that is because when I come here, those shapes, actually, I'm going to do it because I don't think I've done it yet. So I'm just going to say shape. I don't have created yesterday, so shape is a tag. Great. Very easy to search. So I'm going to save the shape. And if I come here and I refresh, I'm going to see this one is going to show up in a second here, right? So I already have other parts that I did or shapes that I did in the past, right? So now I can reuse any of these because I find that all these shapes are interesting for what I'm doing, right? So that is already a fundamental shift in mindset from, oh, let me just put things together and into starting to create a system. That is a big change. It's a big change, for fundamental conceptual change on how you think. If anybody does music, right, which I kind of do if you see all the stuff behind me, right, you can teach somebody chords, right? But if you teach chord progressions, all of a sudden you understand the structure of music. And if you understand arpeggios and triads and stuff like that, all of a sudden you can play solos, you can play everything. You don't have to go and read tabs or anything. You understand how it works. This is fundamental to understand the way things are designed. Can you make it in different ways? Yes, of course. Can you make it effectively? Probably not. This helps much more for that. So, and with all that said, now I'm going to go into what some of you are waiting for. I have this thing in the middle. And so, as you might know, or some of you might know, yesterday, we added a new environment on the 3D editor. Actually, you probably see an apple here, which was not there before, right? And we spent some time figuring out what could be the icon for something that does physics. And okay, well, an apple sounds good, right? And we added, well, this is what we have. We have SimLabs today. So what is SimLabs? SimLabs is a workspace. It's a view of the model that lets you integrate physics. And right now for us, physics is mostly gravity, and also integrate materials, real physical materials, so you can also inspect them and understand what they are. So for example, if I was going to use this right now, I could go to SimLabs. There's not much I can do with them right now here because nothing's going to fall. But I can grab this gasket here, and I would say this is going to be steel. And of course, I can change the color if I want to. But look at this. Now I have mass because I have density of the material, right? So I have the volume of the object, so I have the mass. This already, if you are looking at some level of exercises in STEAM, is very important because you can actually understand how big is this, how heavy is this, restitution, I mean, how bouncy it is, the friction, if you are doing something against, and actually just between us, if you just don't want to do any simulation, they just look cool. They look so well. They look so good. But beyond that, right? So let's not just think about that. I'm going to show you some examples of things that I've seen today. And I was going to use some of the models we've done, but we have had an overwhelming amount of excellent examples coming from you. I mean, from kids, teachers, users overall in the last, I don't know, 24 hours. I just felt, okay, let's just use those. And so, for example, a user, a very very respected user in the community called CMF Design, that's his screen name, came up with this one. And let me just, so in this case, I'm just going to play the simulation. And yeah, the basic, it's not more than basic, but just the well-known sort of Rube Goldberg machine, right? So just throwing the dominoes and then moving the little locomotive that gets that pendulum that goes all the way to the other side, sends something through a tube, and ends up clicking a button that, sorry about that, we still have nothing happening when they click a button, but eventually we might. How did that happen? If I go back to resetting this, the model in 3D is just, in the 3D editor is just this. So this person just put together shapes in the way that you know, right? So these are just boxes, cute boxes with already some, it's not texture, right? Just with some black things there to simulate texture. And then when you go to SimLab, you can define the materials. And most importantly, you can also define if something is dynamic or static. By default, everything in SimLab will be victim of gravity, right? I would say it like that. But you can also define which things are grounded, are static, so they don't fall or they don't get impacted by other things, right? So for example, this one here is static. You can see it here because this is the icon, and this ball, because you saw it move, is dynamic. And this object is static, right? So there's a lot of wealth here. There's a lot of things you can explain to kids by just an example like this, right? There's a lot, and it's fun. And this is a really fun one. This came from, I don't know, at least it's called Filipino designer, so I guess it's somebody from Philippines, and it came very late at night, so probably that's true. And this is amazing. So let me show you what happens here. So this is what this person made. If I take it to SimLab, what's going to happen now is that this element here, right, the wrecking ball, is sort of constrained on this cylinder. So you can imagine that this thing will fall, and this happens, right? This sounds low here because it's kind of constructing the whole simulation. If you now just play it, if you go to share and you just play it, it will do it at a better speed. So, and this is also the artifact you will do to create a video. And of course, if you want to take this to, I don't know, to TikTok, you can just move it around and just put it there and frame it the way you want, and share it on whatever social platform or whatever, or maybe it's just for the kids to then turn that in on Google Classroom, whatever, right? So imagine how fun is doing these things, right? And the last one I'm going to show right now is a Galton board. Why am I showing this one? Because it can teach a very simple math concept, which is normal distribution, right? I think we all know, or most of us should know, I mean, shame on us if we don't know, that when all these balls fall, they will basically create a pattern here, just like a Gauss, right? So let's see if that's the case. there it goes. So if you're a math teacher, and I didn't see a lot of math teachers, or at least people that said we're teaching math, but if you're a math teacher, your eyes should be this big right now, and just thinking about all the stuff I can teach or I can say now about what we're doing. One last thing. Let me just go back to the 3D space, and I'm just gonna take these guys out and gonna do something super basic. Again, don't think of this as a very thought design. I'm just gonna do this. I'm gonna drop a work plane up here. I'm gonna put something up here. And I'm gonna just put another work plane up here, and I'm gonna put this guy here. Let's talk about balance. Is this thing gonna fall? Is this not gonna fall? Right, we can go back to here, and let's say this is hardwood. Let's say just this is softwood, and this is concrete. So I know I wouldn't make, you make up all this is gonna fall or not, but we don't have time. So yeah, miserably, right? So again, iteration, right? This is when you reset, and you can say, and you'll have to go back here and say, okay, well, what would happen if this was here or here, right? How far you have to be from the ends for this not to fall? So you can just check it out, and it's still falling because maybe it's too heavy, and maybe we can just use another material, but it fell differently. It was not that immediate, right? So somebody could say, well, I mean, easy. We can just put it on here and everything will go. And somebody very sort of conservative will say, okay, it will never fall, right? And they're probably right. But at that point, you can say, maybe the problem here is how much material, what is the best solution with the least amount of material under the plank, right? And where would you put those things? And in this case, of course, it doesn't. Oh, wait, it might. Because we know our target audience very well. And who doesn't like throwing stuff at things, right? So imagine this almost like a little bit of like angry shapes, right? And imagine also how that can trigger a whole other set of things, because you could be talking talking about physics and but like static concepts, right? So like equilibrium, stuff like that, and just say, okay, well, just create something that will not fall, or the opposite, it will fall terribly if you do something, if you start throwing things or something like that. So again, that's us kind of staying fun, staying true to our spirit, which is we want to see Tinkercad being very useful and very powerful and very helpful for education, for STEAM education. But we cannot forget our soul, which is fun, right? And we mix fun and learning. That's where I think we hit a sweet spot. And again, for some reason, some people think that learning is not fun, right? And we have to get back to that playing and learning are part of the same thing. So we are just trying to give you more tools to make that happen. With that said, if there are questions, I'm gonna stop right now. And I never got the police telling me to stop, so Kellyanne, so I guess I'm still on time. But are there any questions?
Someone was suggesting we should add glue to our material.
Yeah, well, that'll be the static, right?
But so there was great stuff in the chat, ideas. So this is kind of starting to think about our next chat question, which is how might you use SimLab in your classroom? Someone suggested to relieve stress. Someone also suggested to test out trusses, which would be fun to do in SimLab. Anything else, Randy, in the chat that is interesting, or questions maybe you want to bring up now?
Yeah, bridge design was another thing that came up. Someone wants to throw rubber duckies. That could be fun.
We have rubber duckies there.
Oh, we have rubber
Lobsters
duckies.
are
They just want to know how to
crocodiles.
throw them. You just click in the work plane and I'll throw the rubber ducks. Let's see. Different physics principles like Newton's law and rotational motion.
Yep.
Bridges.
Yeah,
Lots of bridges.
just think of this as a first step, right? So this is, I mean, again, design mindset, product mindset, right? We want to define something that has a story on its own and can withstand alone with whatever comes next, and has value, right? This is what we ship, and then we keep shipping other things later, right? Which add additional value over that one. But again, that's product mindset in action on making software, which we also need product mindset.
Yeah,
and we also knew when we threw it out, we put it out here to you all, you would have better ideas than we would around how would you use it in the classroom. So we are so excited to hear some of the ideas that you have. Randy, did you have something?
Yeah, we're also seeing launchers, levers, catapults, simple machines. But
well, just
in terms
have
of
many
bridges,
of those examples. Yeah.
In terms of bridges, if you're into bridges, you'll love to make a bridge contest on Instructables. But I think there'll be more on that later.
I didn't pay you to say that, Randy. But we will be talking about the Make It Bridge contest in a little bit. So Guillermo has set me up to be the person that has to go after SimLab. But I hope that you find these resources for your classroom to be helpful and to help you think about how you can develop product mindset with your students. So just some resources. So Randy's going to push out some links. When we think about product mindset, central concepts to thinking about product mindset is thinking about criteria and constraints, even thinking about how you might categorize them and think about questions that students could ask themselves as they're trying to take a prototype and think about how it could become more of a real product. So this is a worksheet that's in one of our Tinkercad lesson plans, and Randy's going to push this out. The worksheet also comes along with this sort of like poster or handout where we think about different categories of constraints. So criteria, as we know, are positive features of a design that are measurable. Constraints are limits, so limitations. So students might think about technical limitations to their designs. And one of the things that you can also kind of teach along with this vocabulary of criteria and constraints is also just kind of more vocabulary words and concepts that are specific to actually making or manufacturing a real product. So you could talk to students about what they're making in regard to safety guidelines or certifications. There's FCC, there's UL for electronics and electrical products, there's CE in Europe. You might even think about environmental regulations, ways of making products accessible for people with disabilities. You might talk about making or manufacturing constraints, and then you could get into concepts like bill of materials and also tolerances, which Guillermo was talking about a little bit before. So thinking about the acceptable degree of variability in a product's dimensions. We know that when you manufacture something, it might not always come out exactly the same size every time. So, what are the kind of guardrails around that? You might talk about market constraints. And I know that a lot of students are really kind of interested into this aspect of product design and manufacturing. And there you can also talk about the idea of extensibility. So when you put a product out there, are you thinking about the next steps and how easy might it be to customize or enhance in the future? Even thinking about what Guillermo was talking about with parts collections or shapes collections, how can you teach students to also design in a way that is modular? So thinking about modularity as a concept. This kind of gets into sustainability as well, particularly for thinking about designing hardware. And when you're upgrading it, what are ways that you can upgrade products without it having a bad environmental impact? You could talk about business constraints. So you could bring in the concept of COGS, which is cost of goods sold, which is basically the bill of materials plus labor and shipping. And some students really do like crunching those numbers and kind of thinking about, how, if this were a business, how could we make it real? And last but not least, sustainability, which is just another, area of constraints that students can think about that could also kind of open up doors for them to think about green skills. And also I know a lot of teachers, particularly who join this webinar, teach with the sustainable development goals. So really just thinking about as you're designing products, what is the impact on the environment? What's the impact on future generations? A great lesson plan that was put out on Instructables was this one that was made by a teacher named Timothy Guillermo. I hope I'm pronouncing his name correctly, but he has an awesome collection of Instructables. And he did this really great instructable on passive speakers for smartphones. So this is an engaging project for students because students get to design something, but they kind of have to make it also in order to see if it works. So they need to be able to 3D print it, for example, and listen to it. So he includes these awesome examples. I know that one of the teachers actually had said that she likes to put out her own prototypes to students first and have them improve them as kind of a first step to their projects. So he includes all these links to some of his students' designs. Template. I think this may have been an older instructable. So I've given Randy some links to kind of more updated phone templates if you want to do this project with your students, but he does include a link to the template here. So if you're going to choose to teach this as a project with your students, I know teachers have talked about physics, like, the sim lab is obviously a great workspace for teaching physics. This is also a great physics lesson as well that connects. So you might have students for essential questions like what materials and variables affect how you hear sound, or how does the shape of an object impact hearing? One of the things that I found fascinating in trying to kind of replicate some of the student designs that Timothy's students made is just how important the inside was. Like, it was more important than the actual outside of the model. So that's something that I also will get into in a quick kind of basic demonstration in Tinkercad. So also, when we're thinking about launching these projects with students, we want to think about even individual students. So, thinking about the student who's the curious doer, and Guillermo was talking about design thinking and product mindset and kind of where they overlap and then places where they differ. I think for a student who's someone who really likes to get hands-on with their learning and think about actually making the things that they're designing and kind of really doesn't like to live in the land of the abstract, really wants to kind of jump in and get hands-on. This is a great mindset to cultivate and also to design projects around. Oftentimes when we're thinking about this student who really likes to get hands-on and just start making things, sometimes they struggle to get started. So when we think about this design thinking process that Guillermo illustrated earlier, when we're in that empathize, define, even into that ideate phase, some students struggle with that kind of blank canvas. Some students also, in gathering inspiration might need a little direction. So for a project like this, what I might do is, have students look at, Etsy or Pinterest for some examples of passive speakers. I had actually coached a team of girls that were developing a mobile app. And there was one girl in particular who was not into the coding at all, but when we got into competitive analysis and kind of looking at different, examples of competitors in the market that we could, beat with our product, that was something that really kind of caught her interest. And that was kind of, she did an amazing job doing her competitive analysis report. Another example is you might talk about like the history of, different sound devices. I'm not going to play all of these, but my husband is a collector of music machines. And it's not only a expensive hobby, it's also a very surprisingly loud hobby. So these are all music machines that were designed before people had electricity in their houses. And I'm always just kind of shocked by how loud some of these machines are. For example, the phonograph, it has the big horn, which is obviously a great shape for, amplifying sounds. But then, when you get into some of these later ones, like the Edison Ambarola, they actually just decided to put the horn inside of the music machine because, it was more marketable that way. It was less cumbersome, it was less big, in your living room. And similarly, when we get into like the phonograph, even just the cylindrical Ambarolas were too much to store, too big to store. So then they started to think about how they could slim down the design in that way. So some students are really kind of hooked at, thinking about history. That phonograph, for example, you open the doors on it and it gets like so loud. It sounds like you have like a boombox in your house. So those are just some ideas for places where students could research as part of a project like this. I just wanted to share a quick demonstration of how you might make one of the speakers in Tinkercad. And this is for people who might be new to Tinkercad. We welcome you here tonight. So all you're doing is dragging and dropping shapes onto the work plane. I'm using the rotate tool to just tip it. And then I'm using that black cone to drop it down the Z axis. I'm adding a hole to this. So it's a hole box shape at the bottom because I want to shave off that kind of overhang underneath because I want my speaker to sit flatly on a surface. Might even want to add legs to it for amplification, but not in this example. So what you see me here is grabbing a template. So I just was in a different tab in Tinkercad with my template open and I copied and pasted it. So this is like the real size and dimensions of, I think this is a Galaxy phone. So I'm just using my arrows to move it back into place. And I just want to see how it fits in my speaker. I'm adding a work plane in order to just make sure that I'm staying at that angle of how I want the phone to sit. And then once I know that my phone fits in there, I just kind of got rid of the template. You don't necessarily need it there anymore. So what you see me doing here is just adding holes to shapes in order to change their complexity. And here, when you're thinking about designing a passive speaker for a phone, you also want to think about looking at the phone and where the speakers are. I mean, if I were to improve this design, I might also think about like having somewhere that the charger could fit in as well. And you see me changing. So again, when you're designing a speaker like this, the inside is almost more important than what's outside. So you'll see me changing the transparency of shapes, but you also see me hiding shapes as well, just so that I can access them. So one example that I wanted to share with you in thinking about, when your students are ready to move on to Fusion 360, they might just be ready for certain things, like they might be ready to render, or they might just want to do a cross section. And again, students should be 13 or older in the United States. In order to use Fusion 360, there are different ages and different places. So I'm hitting send to Fusion. I'm clicking continue. I'm clicking send. I have Fusion installed on my computer, so I opened it on the desktop. So I'm just clicking open Fusion 360, and then my design is in Fusion 360. So when you're in Fusion 360, when you hover over surfaces, you can see that they light up, but you've got to click on it to select it. And I just went into inspect, and then I went into section analysis, and see how easy it is now to see what's inside my speaker. I was kind of awkwardly fumbling around in Tinkercad with this. So it's like, this is very satisfying for me to be able to check what was inside the design by using this cross-section analysis. So you can do it on different surfaces. So I hope that this is a project that resonates with you. My puns are always intended. And we're going to move on next to talk to Jem. But before we do that, I had a question for you. So as we're getting ready for Jem to queue up, which websites or communities do you explore or engage with in order to find inspiration for your classroom? We know that you come to these webinars and we love that you do, but where else do you find inspiration? So this should be interesting for other teachers in the chat to hear too. You can maybe have a little notepad open to take down some links of cool places to go and explore. Randy, yep. Anything in the chat?
Yeah, we have Printables and Thingiverse, YouTube and TikTok, Smithsonian, Instagram, Formlabs, Learning Blade, Thingiverse, Instructables, YouTube, Exploratorium, Thingiverse, FabLab, Facebook, Cult 3D, Minecraft, YouTube, Science Buddies. There sure are a lot of different places people go for inspiration.
Lots of places. So keep sharing this with each other in the chat. For the sake of time, we're going to move on to Jem's presentation, but do please, continue to share resources with each other. And Jem is now going to share stories from the shop floor. Jem, please take it away, and you may usurp my screen.
Thank you, everybody. Well, let me get this thing shared now. Okay, yeah, here we go. So, hi, my name is Jemuel Stephenson. Call me Jem. I am founder CEO of a small fabrication company here in Boston. We do design fabrication. You can find us at fabricatorigins.com. I also work with a program called Digital Ready, which Kellyanne is also familiar with. And we're going to talk about both of those things, a little bit about the story, sort of how I, okay, there we go. How, sort of where I come from and things like that. So I'm born, raised here in Boston. I would say that my introduction into the whole kind of makerspace, culture had happened really early. I mean, I guess fairly early on, in my opinion, when I was, I think, about 9, 10 years old, way back in 2005, when they were first starting up. And it was just like a really great experience for me to be able to, as I was always one of those kids that was always drawing and designing and making stuff with my siblings and whatnot, and being able to come to a spot where you can actually realize these things, these tools and things like that. You see the laser cutter. Like I don't think 3D printers were all over the place yet, but you had laser cutters, you had the CNC things, you had vinyl cutters, all these different types of machines. I do remember the first thing that came to my mind. I think that this is something that's lived with me for the past 15, 16 years, is this idea. The first thing I thought, my little self, was, wow, I can literally touch my thoughts. I have all these ideas, all this stuff. And it was just like a big, it was just a huge tool and a huge kind of relief to be able to sort of get all these ideas out and start making and designing. Fast forward, Fab Labs, Makerspace, my first job. One of the things I started to realize was in these spaces was that, hey, everyone's eyes light up, just like mine did, whenever people come into these spaces and start being able to utilize these tools and these softwares and things like that. But one of the things that stood out to me was that a lot of people, and remember, this is like 15 years ago, so like the resources that we have today weren't really around back then in the same scope. But the thing that I started to realize, I was like, hey, people's eyes light up, but they don't really have ways to, like, they can see the potential, but being able to actually execute on these things is not necessarily the forte. And me, seeing this, I'm like, dude, this is going to be a situation where eventually this is going to be like Microsoft Word. You can test and iterate almost the same way that you would with the paper. And instead of being able to produce text on the printed page, we're making things. And so this is what we see nowadays with the digital fabrication, things like that. And this is one of the great reasons why I like to use a lot of Autodesk products, because they pretty seamlessly integrate to actual fabrication, which is sort of what I do now. I specialize in digital fabrication, studied mechanical engineering at Bucknell University. I founded my company back in 2017. Also, I've been using a lot of Autodesk software since, I don't know how long. I've been using Fusion 360 since almost 8 years, since 2015, and I've dabbled a little bit in Maya, Mudbox, 3ds Max, so some of the other programs that Autodesk, and of course Tinkercad. So that's pretty much like the history. Some of these pictures you're seeing on here is like stuff that I was fabricating back in, I think this is 2012. I was actually working with MIT, helping them run their at the time their mobile fab lab, and teaching kids, adults, stuff like that. Literally, people walk in and we make stuff for people, and then they leave and they're like, "Oh wow, this is amazing." For now, I run a fabrication company here in Boston. We do a lot of things like custom cabinetry, bookcases, a lot of woodwork type stuff, islands, furniture, signage. You can sort of see like this nice CNC cut sign for like a sub shop somewhere in Mass that we made not too long ago. Bookshelves, things like that. You can see some of our equipment, laser cutters, CNC equipment back there, and some of the other projects. And one of the things that I like to do, that I feel like kind of helps with this whole integration, is really trying to put as much in software as you can. And so this is one of the reasons why we are really like the Autodesk products and using them to actually be able to do that seamlessly and integrate with my machines and things like that. Also partner oftentimes and work with Digital Ready, which is a program here in Boston that helps high school and early college youth, gain certifications, college credits, and things like that. And real world experience in industry as well, which is a big thing for me, as I'm a person who, obviously needs people to work and likes being able to help other people learn some of the things that I've learned in the past and still continue to learn to this day. I want to talk a little bit about some of the stuff actually that we have done with digital writing, these workshops, especially around Fusion 360. I know this is like a Tinkercad workshop, but I think we've kind of sort of transitioned a little bit. We've mentioned name dropped Fusion a little bit. I want to talk about some of the stuff that we've done with some of our students with this program. There are a couple things we do a lot of like youth design workshops. So again, high school students, so it's not necessarily middle or elementary school students. But we have like month-long boot camps or summer studios, we call them sometimes, or and even during the rest of the year as well, where we've taken some of these Autodesk certificate courses like this Autodesk Certified Associate in CAD for Mechanical Engineering Design. For mechanical design, should I say. We've taken courses like that and adapted them to fit like a 4-week, month-long process where we take all the students through all your extrusions, all things that you might need to do to be able to make different products, and do it in a way that it's fun, engaging. We teach them renders early on because they really like to be able to visualize a lot of the stuff that they're creating, and just really try to engage them. And a lot of the students that come from these programs actually go on to continue in other different fields within digital ready program, where been in college and things like that, and engineering, architecture, and all these different types of fields that are related to this whole design process. That a lot of this can be sparked from this exposure. Also, of course, we're doing product testing, iteration. We like to incorporate 3D printing into our workflows, just so that students can, again, touch your thoughts in that same type of way and be able to iterate and update designs and things like that. This is just some quick examples of some of the stuff that we've done here. Also, another thing that we do that I do with my company is we do apprenticeship programs. And again, I partnered a lot with Digital Ready to do this as well. One of the great things about this is that we bring in some of the students from these courses. Some of them I've also previously taught. And we'll bring them to people who are actually interested and have the acumen for it to actually work in the shop, real world situations. There's real money involved, there's real deadlines, there's real all this type of stuff, and they get to understand, hey, here's some of the important factors, here's some of the things that are not important. You're talking about product feasibility, and talking about how something that you might design in a software program might look good and well in the program, but once you bring it into the real world, it falls apart because, hey, the material is too thin or whatever it is, your tolerances are off and things like that. And they start to see that ideal world is not always real world, and they're able to modify their designs and things like that. And so it's a bit of a balance between making actually physical fabrication and assembling and whatnot, and even sanding, finishing, and things like that, and then bringing it back and say, hey, we just did this, we just made this thing. How can we, now given the fact that you've actually assembled one of these, how can we make it better? And how would you now design it? And you'll really start to see that you'll start to see a lot of difference between their approach initially when they just exposed it, something like Fusion 360. And then after they've actually tried to make the thing that either they've designed or someone else has designed, they're like, dude, this took 3 hours to do this, to assemble this. What if we change the design in this particular way? And now it takes 15 minutes. I'm like, bravo, look at that. You're using design or using products as thinking, you know what I'm saying? That's saving me time and money and upping the quality, because now we can spend more time on, I don't know, quality control or finishing, all these touch-ups and things like that. This right here is actually a cool example. Actually, this is a quick cabinetry style project that we did. Actually, I want to say a couple of weeks ago. And we installed this in a local design firm has a design gym, and we put these things in here. This is some kind of interesting stuff. And then after that, we for the past, I think, week or so, I've actually been sitting down with my apprentices, and we're like, hey, you know what? You saw how that worked. Now it's your turn. You guys turn to design and actually build one of these things for, in this case, you know, let's say our shop particularly. You know what I'm saying? How would you design something like this? You use this all the time. How would you make it? So that's like a really great thing, and they enjoy it, and it's a good thing for, you know, all parties involved, because they're getting experience, they're getting training, they're actually getting paid for it, which is awesome. Not all programs are like that, but you know, it's good stuff. I did want to give a little demonstration of, since we do use Fusion 360 a lot in our workflows, just a little bit of a demonstration of how we actually might go about building something as simple like a TV console. This is like I was sitting in my living room the other day and I saw the TV console. I was like, hey, let's actually just go ahead and build this. One of the things that we do a lot in my business, and I think Fusion 360 is really good at, is this whole parameter situation. So you can sort of see how I'm inputting. I'll pause it actually just really quickly. You can sort of see I'm inputting all these numbers and these I'm assigning these values to these parameters. So width, height, depth, thickness of material, you know, the width of a particular cabinet section on the thing, an offset, you know, and these things are stuff that they're able to learn from first of all, clients saying, hey, I want something this particular size or whatever. But like maybe the offset comes from, hey, you know what, I tried to make the shelf fit and it was too tight because the tolerances are off. Now they know that they need to actually add these things in. You know, here I'm just defining a lot of these things. Fusion 360 is really good with this. I like to do this I like to outfit my parameter table as much as we can before even starting any sketches. And it's a good thing about this program is you can always go back and change and modify it as you go along. And this is a thing that we've grown to use a lot and rely on. So of course, we're just going ahead and making these, making this basic, this first set of geometry. You can sort of see the FX in front of all the dimensions that we're adding. That means that it's actually linked to some parameter, and in this case, values from the parameter table. Again, this is very simple design. It's just a few basic extrusions and things like that. But another really fun thing that you'll see in just a minute here is the rendering portion of Fusion 360. Again, this is huge for my business as a furniture designer and fabricator. Being able to show clients like all the different types of woods and materials and things like that. And I've really enjoyed watching the Autodesk, the materials library grow over the years, and adding different types of materials and different ways to actually process and edit them. So you can sort of see me here just going and throwing in some material properties there, saving it, doing a nice little render here, change the color of the texture of the wood, which is actually really cool to be able to do. And of course, you can see I opened that door. Fusion 360 has really good, motion integration as well. So we're able to do a lot of that. And the cool thing about it is that you can see I just went in there and I changed just off whim. I was like, you know what if we made it 65 inches instead of 50? I don't have to go back into my sketches and do anything. I can just go and change just a couple things in the parameter table, and boom, everything's updated, which is really, really nice. That saves us a lot of time and money in production, in sale, and just design time and things like that. Let's go to the next slide. Yes. So here's some of the results from that. Again, look at these. Look at the renders. Renders look great. We've noticed that a lot of the reasons we really like this software is, first of all, for all the things that have been said already, it's built into Autodesk suite of software already, so it can integrate very well with things like Tinkercad and stuff like that. So, students can come in and do, and take their designs and, use them in the software. It's cloud-based, so that's huge for project sharing. I mean, that's really great for classrooms. Also, if you can imagine, great for clients if people love to be able to manipulate their designs and things like that. And then of course we have already talked about the parameters and things like that. And then also the CAM that is built into it allows us to actually physically make these things, and generate toolpaths out of Fusion 360, which is huge, so that I can, basically, like I was saying, print, in quotes, to my CNC, or print to my laser cutter in ways, and create these sketches and DXFs and things like that. So this is part of like how we integrate Fusion 360 into our workflow here at Fabright Origin, and how we can actually use it to engage with youth, engage with students, and help to just help them along with their desires of actually becoming, architects, becoming engineers, becoming designers, and just fuel their creativity. So yeah, that's pretty much my presentation. I think the question I did have for you guys is, what local businesses or institutions around you guys offer training, industry exposure for students in STEM? I think because there's huge resources, to be able to have an honor to be able to, provide those kinds of resources to the students. And it's very curious to see what you guys think.
Well, Jem, you provide an awesome example and a model for others to be able to do that.
Yes, indeed. Thank you. All right, I'm going to stop sharing my screen. I'll let you guys chat amongst yourselves, and yeah, I'll turn it back over to you, Kellyanne.
All right, I'm going to share my screen again. And just one of the things, Jem, one of the funny things that you said was, this is just a simple design. Because one of the things that I think about, like when you had shared that idea about like being able to touch your thoughts, it brought me back to thinking about the first time that we did a webinar together for students in Boston. The way that your mind, you're able to go from 2D to 3D, like that you can, think about kind of manipulating shapes in your mind, is just something that so blows me away every time I talk to you. And I think of this like idea of like mental origami. And I feel like you must have cultivated this gift from such a young age.
Funny story, if you mind me chiming in really quickly. That's exactly true. So one of the interesting things that, and again, I think this is kind of due to my computer being kind of slow when I was a kid or whatnot, but I used to use things like OpenOffice or Inkscape early on to design a lot of my 3D geometry, but I'm using 2D stuff. So everything was sketches. And so doing that kind of helped me kind of really hone in that type of skill. And by the way, one of the things that we do, even in my company right now, is we really try to minimize the number of sketches that you have to make per design, and see how you can, if you can make something in 2 sketches, I think I only use like maybe 2 sketches in that drawing. Do that. Yeah, I could have used 5 or 6, for every single part, but no, let's simplify it. You have a lot more concentrated information.
Creativity within constraints.
Indeed. Yes, indeed.
Thank you, Jem. So just for the sake of time, because I know it's getting late for teachers, do continue to tell these stories of local businesses in your community. I just want to make sure that we have time at the end to do a live question answer. Before we do that, we just want to share a few announcements. So Randy queued this up earlier, but one of the contests that we're really excited about that is over Instructables right now. This is a student design challenge. It's for students ages 13 to 21 who are in secondary, so high school for the most part. And this is the scholarship award contest is open to students in the United States and Canada. But this is also, it's a challenge that has resources that, you might use, even if the students are not entering the contest. So this is the Make It Bridge Student Design Challenge. We are offering 2 $10,000 scholarship awards, 4 $5,000 scholarship awards, and 10 $1,000 scholarship awards. And this contest is running until the end of June. The design prompt is for students to rethink a gap that exists in their community by designing a structure or space that includes a pedestrian bridge to offer something more for the people and places it connects. And as you see in the bottom left-hand corner of the screen, this contest was inspired by a project that was created by the research team at Autodesk in collaboration with one of our customers, DAR. in which they actually 3D printed a pedestrian bridge in our office or in our research and development center in Boston. So students do have access to this bridge as a starter model. It's in both Tinkercad and also in Fusion 360. It also kind of goes along with the story that we are telling, which is in collaboration with James Devlin, who is formerly of the New England Patriots, 3-time Super Bowl champ. And this year, we are also welcoming Connor Clifton, who is a hockey player for the Boston Bruins. So they both have backgrounds in engineering, and through this web series called Bridging Gaps, they're able to kind of tell their stories and connect with the next generation and hopefully to inspire them. So that's the Make It Bridge contest. We do have this cool hockey graphic that I couldn't help not share during this episode, made by Christian. And also just our next episode, we hope that you tune in. April is Robotics Month. We're going to be talking about introducing robotics with Tinkercad. We will be joined by Kevin Smith, who's the STEM program manager over at Mass Robotics, and also Donald McCoy, who currently works as a K to college STEM consultant, but he also worked at IBM for over 30 years in multiple roles, including electrical engineer. So he does a lot of great work with young people now and kind of helping teachers think about how they can kind of implement this engineering mindset with the young people they love. So we have one more poll. So Randy, you want to take it away? So after today's session, how likely are you to use something you learned in today's webinar? This is where I feel like we're being graded. And do please be honest. You won't hurt our feelings. We want to make sure we use these polls in order to think about how we're going to create future episodes that are useful to you. So we're seeing a lot of very likely and also likely, which is great to hear. Thank you. And thank you for sticking around. We know that we went over. Randy, you want to end the poll?
Yes, I will. Great.
Right, and then just this slide. So you'll be getting these slides emailed to you. I believe it's on Monday that you get the email. And here's all different links for you to stay connected with us until our next episode. We also, for attending this webinar live, sorry if you're watching this recorded on YouTube in the future, you will get a certificate emailed to you saying that you attended this. We wish we could give you the world, but right now we can give you this certificate, and we hope that it's helpful for you if you're using this as part of your professional development plan. So that's all we've got for the formal presentation, but I would like for us to stick around at least for a little while to answer some questions. Randy, any questions that, or did anyone who is answering questions have questions that might be good to share with a larger group? You're also welcome to ask questions in the question and answer too. So new questions are also welcome.
We got the very popular question, where do we get our shirts? If you happen to be attending ISTE this year, you could come get a shirt. So come see us as ISTE if you're able to make it out to Philadelphia. Oh, someone's asking the best way to learn Fusion 360 if they've never used it before.
There's a what is it? The Learn Fusion in
90 minutes.
90 minutes is a good one that I recommend. I don't know if there's something newer. I think that was updated like last year though.
Yeah, there's a self-paced learning also that you can reach even from Fusion itself, from help. You can get to that, which is pretty good. But the Fusion in 90 minutes, it's not only good, it's also more updated to UI and new features and everything. So I would start there.
Another question we have in chat is, what does SimLab translate to in terms of other Autodesk products?
Good question. I mean, I know everything has to have a clear translation, but Fusion, for example, has event simulation. And it's one of the many simulations in Fusion, right? So it's funny, Fusion doesn't have the one we have right now in Tinkercad that's simple, right? But there's a way, there's one of the simulations called event simulation, and that is somehow kind of a little bit like this. So yeah, there's you could say you can start here, you can understand basic concepts, and eventually you want to go into more accurate stuff, right? I will not design a building based on SimLab, right? I would make sure that you understand the basics here, and eventually, if you're ready for something a little more accurate, right? But also more complicated to understand and to learn and to apply. Simulation is a very hard discipline, right? It involves understanding materials at a level that it requires a PhD on materials to get that level of understanding. So it's more complicated, right? So yeah, there's some simple things you can do, but to fully leverage analysis and simulation on any application out there, professional, it's a life choice.
Jem,
there
any years?
are 10,000 plastics. There are 10,000 plastics to choose in Moldflow.
Wow.
10,000.
Do your students use simulation at all when you're using Fusion?
We use some animation. We haven't done like FEA analysis or anything like that that much, which is because a lot of the things that we do don't bear that much weight. It's not like big structural houses or anything like that. But yeah, we do like animations and things like that, and some you do have to like look at tolerances and things like that. But from that, like apart from that, we don't do a whole lot of like simulation. It's not a whole lot of movement with the kinds of things that I built.
So we've gotten a few questions about when is the time and date of the next webinar and how can I join? Or how can I get others to join? So I think that's an easy one.
It's easy if you're someone who's not like challenged with dates. We've set it up as for the most part, they're the last Thursday of the month, right? So and I just said it, I think it's Thursday, April 27th, I think is what I said it was, right? If that's a Thursday. And then it's 7 p.m. my time on the East Coast. So it varies where you are. And then the other one is May. I know the next one is May 25th because it's my mother's birthday.
Will the instructions, will these recordings be posted online? Will the resources be available for people to find afterwards?
Yeah, so the slideshow is going to be emailed to you all. I believe I have it set for Monday. And then Nicole will probably put this up on that playlist tomorrow. I'll share it with you in the morning. So we usually have the YouTube video up pretty shortly after these. And we do love it when you stick around and stay and engage with us because it's much more fun, but all the recordings will be there. Any other questions?
Not seeing too many right now in the chat. Does every webinar have its own certificate? That's yes.
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 And I try to make them a different color every time.
Yeah, there's really no other questions at the moment.
Well, our teacher friends might also be tired, particularly on the East Coast where it's 8:30 right now. So we do really appreciate you all sticking around. Randy, was there one more?
Yeah, there's a question for you. What does your husband like to listen to on those devices? What's his favorite music?
It's not necessarily favorite music. It's like he likes things of the period. I can't think of all like the old timey. I mean, he loves Duke Ellington. A lot of like old jazz type stuff. Mildred Bailey is someone that he really likes to listen to that I think that we have on the olds. Amberolas, and I think we have an Amberola with her. But yeah, so a lot of old music, but then there's also just some artists who were very popular at that time that it was a different time with different musical tastes. And that's all I have to say about that. And those recordings, I didn't want to go through all of them, but that's in the slideshow too. So if you think your students might dig listening to those, I played them for the digital ready students when we did the passive speaker. And they at least seemed to like it. So that's in the slideshow too.
I think that's all we really have thus far in terms of questions.
We are so grateful for you to stick around with us. We hope that you enjoyed the webinar. We hope that you play with SimLab when you have time, maybe tomorrow, maybe over the weekend. And we also just want to thank Jem for being such an inspiration for us tonight, and also for the students and the young people that he inspires. I also had the same t-shirt as you, the Blick t-shirt that you're wearing when you're little. So we can be twinsies later. And also just thank you to Guillermo for sharing SimLab with us, and also just all he knows about product mindset, and the extended Tinkercad team for sticking around to answer all the questions. So we hope that you join us again for the next webinar. I'm going to make a guess that I think that I said it's April 27, but if I'm wrong, you can go back and refer to the slides, and we hope that we see you again. So good night, everyone. We usually do an awkward wave at this time, so if you want to. All right. All right. Thank you all. Have a good night. Take care.